Hey, what's going on, guys? Xiangqi here. In this video I'd like to introduce the evaluation function for our Xiangqi chess engine. So nothing really much to type code here. I just want to quickly walk through how it works, but before that I'd like to give a credit for those guys from whose sources I've taken the evaluation parameters, because I have no idea what they should look like, at all. So eventually I took the evaluation from parameters from Mark Dirish, who's created quite pretty nice CNC engine. Well, it has a fantastic GUI, so definitely should have tried this. Just download the source and click index.html to play with an engine. It's very nice, but it has quite pretty rudimentary search, and as I could have concluded, it doesn't have quiescent search, which is a little bit strange. But anyway, in Mark's sources, I found this credits to the initial sources. Okay, so material weights are taken from the Computer Chinese Chess Journal, and p-squared table weights are taken from the UCLA thesis of Xiangqi. He was using this AdaBoost to implement Chinese chess evaluation function. So it seems like some sort of a machine learning algorithm was involved in order to obtain these values, which is really interesting. So we'll see how it plays. I have no idea. I didn't test that yet because we don't really have a search, but this would have been incredibly interesting to have a look. So I needed to adjust the p-squared tables to fit the format of my engine. So initially they were shown from the black perspective, so I mirrored them to show from the white perspective. Also, I made them fit the board layout here. So literally starts from here, from this corner, and ends up in this corner. So these are the values. So material weight, quite pretty trivial. So plausible for whites, negative for blacks. So assuming the Nigamax framework that we'd be using within our Nigamax within our search alphabet search algorithm, we would need to return positive score for whites and negative score for blacks. That's the very casual things, the very casual way of doing things. So we would be evaluating only material weights and p-squared tables. I don't know, maybe one day I would add insufficient material as well, but at the moment I was asking I was asking one Chinese chess coach on YouTube. I'm sorry, I don't know his name because it's written in Chinese and didn't Google Translate that. So I asked him, is there a condition for insufficient material, because it's a little bit tricky for me to come up with that answer on my own. But anyway, we have the piece values, and I was quite pretty excited by the fact that the pawn value is so less compared to advisors. It's not the same as in Wikipedia or chess programming Wikipedia as well. So it's quite pretty different values. And it would be incredibly exciting to watch how these values would be actually playing the game of CNC. Regarding the p-squared tables, I can't say much. So we have pawns, kings, knights, cannons, rooks, and we skip kings and bishops and advisors because nothing really. So they just kind of working on demand. So if you need to defend, they step into. Otherwise, it's no need to touch them basically. So yeah, so this little array evaluate type simply lets us know which p-squared tables to use for evaluation and which to skip. So in case if we have this advisor, bishop, and king equal to 0, we're just not going to be referencing them, so literally skipping them. Otherwise, I would need to add the empty boards. That's a little bit too much from the size from the code size perspective. And also, this mirror square is needed in order to convert scores, p-squared table scores from the white perspective to mirrored from the black perspective. So that's quite pretty simple. I could have duplicate, but that seems to be a little bit of unnecessary job. So we can simply just map the squares and that's it. And now the evaluation function is very simple basically. So we have the score that we would return in the very end depending on the side. So if the side is red, we return plus score, otherwise minus score. Then we loop over all of the board squares, make sure that the square is located on the board, so it's not an off-board square. Then we need to make sure that we have something at the board square, literally a piece there, so make sure that the piece is available. Then we want to extract the piece, so literally what we have at the board square. Then we obtain the index to index p-score table, so we're using piece type and subscribing 16. The reason for subscribing 16 is the following. So if 1 is equal to 16, so 16 minus 16 would be 0, so this would be 1, 2, 3, 4, 5, and 6 respectively. And if we have a look at our PST, these are the exact indices we want to use. So we want to use index of 0 to get the scores for pawns, skip 1, 2, then 3 for knights, 4 for cannons, 5 for rooks, and skip 6 for kings. Quite pretty simple. Then we distinguish in the color, because depending on whether the piece is white or black, for p-score tables we would be either adding the score or subtracting the score. While with the material weights we don't need that, because we already have plus and minus weights within the material weights. So here we just index material weights by the piece code itself, and we get the relative piece value. So let's say if the index is 1, which is white pawn, we get this plus 30. If the index is 8, which is 0, 1, 2, 3, 4, 5, 6, 7, yeah, 8, we get this minus 30, which means the black pawn, red pawn, black pawn. That's it. So quite pretty simple. So arbitrary big number for king. So all these numbers should be working in cooperation. Again, like in Mark's sources, I didn't see any information regarding how well these values interact with each other, but I try to play with his engine and it seems to be making quite pretty reasonable moves. The search is poor, but from the evaluation perspective, that seems to be very interesting to play with. So no ideas how likely this is about to be working, but I think that this should be just fine. So if you just very last little idea, a little test. So here print the score for the initial board position. This is equal to 0 because we have equal material and equal position. And I would just try to play around by with the scores by slightly changing the position. So well, let's try to grab this initial FEN, copy, and let's try to set board and bring it in and save, and okay. Now let's try to take away, say, this cannon. So I'll try not to predict the value. So material weights. So we take the cannon, the score should be minus 285 because black would be better in this case if we take away the white cannon. So let's try to take one cannon away, save, and yeah, we have minus 285. I just didn't yet test this, but I believe this should be working perfectly well. Okay, so now let's restore this, and now let's just try to reposition the cannon. So let's say cannon, and 5. I have no idea what score is there, but there should be a slightly bigger score. Okay, we got this 8, so let's check this. So we have 1, 2, 3. Okay, so let's go to PST. Go into PST. Let's find the cannon, and the rank is 1, 2, third rank. Yeah, first square is second, third square gives 8. So this is the exact bonus that cannon would take, but most likely would be moving here, okay, to the center. So that's how it goes basically. Yeah, that's how it goes. This would be forcing this very standard opening where when the cannon steps into the center, opposite the opponent's king, attacking the pawn, things like that. And actually it's a bad idea. You see, like even I can understand this, that actually the cannon from here is discouraged to take this pawn, even though it's possible, but it's been discouraged because probably that leads to some sort of a tactical disaster. So this is it, basically. This is it, guys. Now we would be calling evaluation on the leaf nodes of our search, and I hope I will prepare the entire search function with all the bells and whistles to the next video. The only difference from standard chess, I mean international Western chess, would be just slightly different draw repetition scoring. So we would be score. I had a consultation with Harmgerd Müller, who has described that there are really lots of issues with the full-blown implementations of all these nitty-gritty rules regarding repetitions in general, because the side that forces repetition actually loses. So he came up with a very simple solution. So just to return the score slightly less than a knight or a cannon, to make sure that if we are already losing, then it's not a big deal to force this repetition. It's like if we would claim that we're resigning this position because we are already bad enough, so we can resign. No sense to play. But on the other hand, if we are better, then this might be leading to sacrificing a couple of pawns, but also that might not be that actually that bad thing. So no ideas at the moment how it would be playing, to be honest. So I'm really tempted to see that on my own. So in the next video I really hope to bring search into life. Then probably I will still I will quickly just grab the UCI protocol, probably even not converting that to UCCI. I don't know. It's a bit of a questionable still. I can hardly believe that Chinese guys would be taking my engine and trying to play with it in their own GUIs they're using. I don't think this would happen ever. But if this sort of request would ever to come, that won't be an issue to slightly change the protocol. So probably at the very end it might be supporting both protocols, like UCI and UCCI. They're just a little bit different, but in essence they are the same, just the commands a little bit different. And that's it basically. Yeah, and then we'll go to implementing the GUI. Again, like I would be deriving the GUI from the Wukong.js, the International Western Chess variation of my engine. And I hope this is gonna be quite pretty interesting to see this Chinese chess Xiangqi board instead of the westernized one. So instead of the Western chess board. So this is it from my side, guys. I think yeah, I think this is it. I think this is it. Just to give you a very brief idea of how the end result is supposed to look like. It's supposed to look like this, but with the Chinese board respectively. You see, like I've been preparing background image for a long time basically. I'm not sure if the FVN recording would be, probably I will keep that. I think I can keep that. Also here I would be probably changing the pieces from Chinese to traditional to westernized pieces to romanized pieces. Here the bots or skill levels also should be the same, so literally the same, but just a different board and a different game. I think that's the way to go. Okay, so this is it from my side. Thanks for watching. Until the next time, and take care.